Okay, thanks for the introduction. First thing I'll say is if you're here with your boss and you want to work for HealthStream, give me your business card and then I can refer you and get the referral fee for it. So, and I've worked with Davis before as doing some consulting work, and they are good people, good shop to work for if you're looking for a position with them. So SQL 2012, first edition that SQL Server's had out since version 7, where I'm actually recommending to all my clients, whether they're on SQL Express or Enterprise Edition, that there are worthwhile things for them to upgrade to. Because as we all know, usually in the really cool stuff, that I come across aren't on the Enterprise Edition. There's a lot of things that go throughout the platform all the way down to SQL Express. So information about me, don't worry about trying to take notes or write down things. There'll be links and whatnot in here. Code samples, I'll give them to the Nashville team. They'll, I presume, put it up on the website somewhere for subsequent download. So been doing just the relational engine since 6.5, so I actually could work on that 6.5 database if you really needed it to, although I think there's 19 steps you have to go through to upgrade it to SQL 2012. Very devoted to my career, a lot of effort put in both personally and professionally to be one of the best in the world at making SQL Server applications perform and scale well. Really love to do mentoring. That's one of the reasons I do a lot of SQL Saturdays. I did 18 of them last year, and I'm coming up on my 50th SQL Saturday here early this year. I do all kinds of other community involvement and things like that too. BI, like Jessica, I would not be the person for your BI position that you've got there, but I do know some world-class people if you do have that kind of need. I'm purely a relational engine type of guy. So we're going to look at the windowing functions, what they are, why they're important. We've had, if you remember when 2005 came out, there was this thing called the row underscore number and then over, and you could do some really interesting things with that. That just really was the tip of the iceberg for what you could do with the full ANSI capabilities of what's known as windowing functions. And Itzig began and a bunch of others, a lot of the MVPs really drove Microsoft to get more heavily invested in this. And we've seen the fruits of that labor come out in 2012. Really a number of options for things that we can do and some very interesting classes of data analytics and problems that we can solve using windowing functions. Also want to give a quick shout out. Like I said, I love doing SQL Saturdays and presenting a bunch of user groups, but I'm fairly busy as an independent consultant. And I actually don't like to write. So I don't usually do my own material. I actually borrow from the goodness of others, and want to give a shout out to Shai Engelberg, a friend of mine in Israel that wrote the deck for this, and I've expanded it and added some stuff in from Aaron Bertrand and Fabiano Amarim and some others, and you'll see some links and some slides from information that they gave me permission to incorporate here. So the reason that they're important is they're set-based and usually very, very efficient at doing solutions for problems that heretofore were extremely inefficient, possibly not even possible to do in T-SQL, or which required something like a cursor to actually be most efficient at, which, believe it or not, as bad as SQL Server is with cursors, and they're really bad compared to other platforms, for running totals, SQL Server T-SQL cursors are actually often your best recourse, believe it or not. So things like paging, deduplication of data, top ends per group, percentiles, gaps and islands, all of these have, and many other things, have new solutions that you can use with the windowing function capabilities. So the over clause we saw started out with a row number in 2005. They haven't really done any improvement with that. 2008 and R2, no new functionality was added. But with 2012, there's some huge, huge changes to what we can do with the over clause. So now we could do before partitioning and ordering. Give us exactly the same behavior as we have now as we usually existing code. But as we'll see, that default that they chose is actually very suboptimal from a performance standpoint. Let's take a look at some of those. So the partition bucket, I like to think of bucketizing the data. If you have a stream of numbers, you can partition them by, say, if it's a product ID, you can say I have product IDs in them, and I want to bucketize. For product ID 1, grab all the rows and do something. For product ID 2, grab all the rows and do something. Or for dates or date ranges or things like that. Order by is obviously to put a set of rows, and it doesn't have to be all of them anymore, and it can be a partition or within the partition, to put those rows in a specific order so that we can do particular processing, such as first or last, or a number of rows ago or a number of rows forward. And then the rows arrange, limit within each partition, if there is one, if not within all rows, a subset of those rows that you can act upon as the data streams through the process. Okay, looking at the frame, and it's done by specifying a number of rows or a range of rows, again, as the data streams through, either by logical association or by physical association. And remember, if there's an order, you can actually specify a physical number of rows because it sequences from 1 to n in the order. So that both of those capabilities give us some very nice functionality. So within a partition, you can do a fixed number of rows preceding, a fixed number of rows following, or the actual current row itself. And each one of those things can give you options within the T-SQL construct that we're going to look at. The range clause is relative. You can say, I want some number or range of values, not specific data row counts, from a point or to a point, based on the current row that's streaming through. And again, hopefully when we get to some of the graphics, this will make a little more sense. Very, very important. Range, which is the default. Some very suboptimal characteristics in the V10 release, which is the SQL 2012 RTM for windowing functions. Fabiano Amarim did a 3-part blog post on the windowing functions, and the third one of those has some really interesting metrics on the performance comparisons between range and rows. Okay, so speaking of the limitations that you can do, unbounded preceding. That means if there's been a billion rows that have come before right now, keep track of all of them and then allow me to do something based on that particular range of rows. A specific number, right? So say you're doing quarterly based metrics and you want to see 4 quarters ago, that would be 4 in the count of previous values. The current row itself, unbounded following, which is from here to however many rows I'm going to get to as I'm streaming the data through. Number following, and also the between clause. Okay. So running totals, very, very common. Many of the clients that I've come across, almost all of them, have had some form of need of running totals. It's just a very, very common, whether you're doing financial, insurance, healthcare, warehousing, transportation, manufacturing, it really doesn't matter. There's a lot of times where you need to know some period up to now, iteratively, right? So it's a very common class of problem, and until these came out, really, really inefficient. This is one of the types of queries that you can do, which is to join the table on itself by a less than or equal to clause. And this is known as a lot of people call this a triangular join. And it actually has quadratic inefficiencies. So as the number of rows go up, you hit the square of the number of rows is the performance degradation that you get. Because you're saying for every row, go check all of the ones that have a date less than this. So the more dates you have to check every one of those for every row that streams through. Grotesquely inefficient. It really, really is. These examples here come from, I believe, a blog post that Aaron Bertrand did. Very well-known MVP, also works for SQL Sentry. Really, if you're not reading his blog and you're an engine person, you're doing yourself a disservice. Another way that you can do it is written as a query like this, okay, which again is an inline, basically reselect, if you will. But again, there's the killer. You're doing a join or a hit on a comparison that's a less than. And whenever you see these, it's really not. And that was a pretty small table, by the way. But the problem is for each row in the table, it has to hit all the ones that have a date less than that. And it's really, really inefficient. And this chart did come from the blog post that Aaron Bertrand did showing performance comparisons or analytics of various solutions to the running totals problem. Itzhak Ben-Gan, in his book, which is new, SQL Server 2012 Windowing Functions, you need a copy of that. You really do, if you're going to be moving to 2012. There is a copy. He has one. I have it in my library. It's one of the very few SQL-type books that I own. And if I've got it in mine, you probably want it in yours as well. But the first two that we looked at, the subquery and the inner join, number of reads, and I believe this was for just a 10,000 row table, if memory serves. Hundreds of thousands of reads and 35 and 60 seconds to compute the running total. Cursor, less than half a second. Okay? That should really tell you something there about how bad the solutions are, the quote, set-based solutions. There's other ones that we'll look at here. Windowed with the range was 215 milliseconds. The windowed with rows, it was so fast, the metric he was using as a tool to capture the performance metric. He had to wait for a second so that the tool would actually, I believe it was the performance analyzer from SQL Sentry, it was too fast to catch by that application. So he had to do a wait for 1 second just so it would show up. It's actually 0.04 seconds to do the running total. So let's take a look here at some of the stuff for the over clause. And we'll be using AdventureWorks 2012. There's like 7 flavors now of AdventureWorks going way, way back. You can get them all on CodePlex. I think there's several flavors for 2012. There's a standard, there's a DW, there's a light, and then there's a big one that you can use if you're doing like big data warehouse or you want to do column store index type stuff where you really need large volumes of data to be able to show how well that performs. So I've got Profiler up, okay, and it's running just batch completed type of stuff. And here is the classic row number over partition. So we're bucketizing by job title, and then we're ordering by business entity ID in a select. Okay, very, very efficient. And as you see here, as job title is the same, it keeps my numbers, sequences, and there's my row number, which is a simple 1 to n per bucket because I have a partition. Everybody follow on that, hopefully. We'll also turn on our execution plan so we can see how things flow out. So we can also do count over. We don't need to put stuff in the over, right? And what's that going to count? Everything. So now I see the total number of rows. But look what that does to my performance. I went from 9 reads without that count star to 619. Now part of that is because I enabled the show execution plan. Believe it or not, the act of observing that in Management Studio really affects what you see in one or the other. Rows as you're streaming through, and then output that on every row itself. Okay. So some of the new capabilities. So actually this one using the partition by with a count. So now I have a count star over partition by. And again, the count actually is going to be mirroring the row number, because that's what the row number does, is it counts from 1 to n, and the count star is doing the same thing now, but I didn't used to be able to do that. Okay. We'll look at a sales date range here. Simple tables, date of sale and sale amount. And I've got sales people who have a territory and an amount that they sold. Okay. New T-SQL format, right? Based on .NET CLR type stuff under the covers. So if you're a .NET developer, you can now do formatting in T-SQL based off of the common .NET format stuff that you know. All the little, characters B and uppercase D and lowercase h, that stuff is exposed to you. However, I always encourage developers to think about 2 things when they're writing T-SQL code or doing stuff in a database. One, does it Okay. Okay, so we're back. And really small table, 76 reads. Note, by default, try to use rows because of the performance hit. And I think we'll have some examples about that as we go through here. There's a type of index in there called a POC, P-O-C, which is partition, order, and contains all of what you need covering. And if you have those type of indexes that you do Windows. Rather than old mechanisms for having to do this, like joining the table with a row number to where row number is -1 or equal 1 or things like that. Okay. Now, some of the limitations, again, the first and last value must be in the source result set, and you can't get only one row if it's matching, if it's actually the first to last. But we'll see a little workaround for that. So here's one of the visualizations. Thing, right? Partition by customer ID, order by order ID, as first order ID from orders where customer ID is in 1 and 2. So, customer ID 1 is grouped together because I've partitioned by it, so they have to be arranged in order so that the partition will actually work. That's my bucketizing by customer ID. And it's ordered by order ID default is ascending. So 10643, that is the first value because that's the first row I've seen as the stream processes through the event. Okay? Everybody with me? Next row hits. Order ID 10692, that's the next biggest in order of order ID. That number is bigger than, 10643 is still the first one that it hit. So it still carries it because it says first value, which is first row. And all the rest of the rows for customer ID 1 still go through the stream, but the first one to hit in order of order was 10643. And that's carried on every row for output. We get a new partition. Grabbing them until it hits the actual last for the bucket, which is 11011, and it actually puts that as the output for all 6 of the rows as it eventually streams them out. Okay. Back of the rows, so the bucket, the customer ID changes, and then it can flush and stream all of those out. Right? It can't release any of those rows until it's seen the last one per bucket. Okay? Questions? Yeah. Aha. Good question. What if, instead of saying unbounded following, I just let it be current row, which would be the default? What if I didn't have any, if I didn't put a framing clause at all in there, it would be range unbounded preceding the current row. Then what would your last row be? For every row, it would be the current row because that's the last one you've seen as the row streams through. Very good observation, and there's actually an example in the code that you can see that happen for. Okay? Be really careful, therefore, when you're doing last value, that you make sure if you want the last per partition or all rows if you don't partition, you better say unbounded following, or it's going to get cut off for every row that streams through. Okay. Or if you could say, I want 100 rows following. And then it will take and literally jump ahead 100 rows and make that your last value as all the rows stream through. There's really a lot of interesting things you can do with this. Works 2012. First value. Now, here's a case where that little correlated select in a select, right, is actually really efficient when you have small numbers of rows. Because this says actually the plan or the actual effort itself. So be wary about that. I usually always run things at least twice. Another reason also is that you might be lifting data off of the disk, which is really slow. And so the second time you run it, it's in memory. So that might be a comparative point for you as well. But the query plan for this, okay, is as we expect, it goes in for each one of those. But look what it does. It says, aha, you're going to be hitting that again and again and again, and it's a top order by. Ooh, the spool makes it actually really efficient. That's why there's very few reads in that. Okay. So the query plan, again, we've got our nested loop there, right? That's the actual first hit of the main select. And then the subselect sends each row in a nested loop back into the table, ordered by, and it spools it so that it knows the first row order by order ID, it's very efficient once it puts it in the spool to just check that instead of going all the way back to the table. A lot of times you'll see spools in plans, and it's not a good thing. Okay? In this case, it actually is. Row number, another common way we can do it, using the CTE, right, common table expression, row number over order by business entity ID. But here, what I got to do is a cross join where row number is 1. Gives me the right answer, right? But now I got the sequence project from the row number over part. Again, it's spooling it for efficiency's sake. And we're looking at 12, about the same plan. Okay. We can bucketize, partition by job title, order by business ID, right? So now I'm saying break it up and do groups of them. There's 3 rows. The first one, as we can see, is 242, and it carries 242 as the, quote, first value within that bucket, that partition, for each one of those rows that are output. Again, just to sequence project the costly sorts, which we don't have if we have an index that's helpful for this. Now, Denali, now, I just got to say that that's just a really much simpler T-SQL statement, right? First underscore value of this ordered by that. It just kind of makes sense. And again, we get that long kind of streamy plan, right? But it's a single hit on the table. That's what's important here. A single hit. But look at the cost. Wow. Right? What happened? These things are supposed to rock. Itzig Ben Gan says so. So let's take a look at what happened. Anybody know why it's so inefficient? I've mentioned it a time or two. Row versus range. Because the default is range, right? And I didn't specify, so it uses a default. Unbounded preceding the current row, range unbounded preceding. And the way they built it in the engine, the problem here is that the range stuff uses disk spooling. Row uses in-memory spooling as long as the engine at execution time says there's enough memory to use it. If it doesn't, it will get flushed down to disk, just like any type of memory or a sort or something like that. If possible, it will exist in RAM. Well, I've got 290. That's the biggest one. How about that? It's the same plan, right? I'm just changing the order by. Same thing with 2005 and the row number, order by descending, simple change. Last value, oops. And the gentleman over here asked the question that we already know now why that happened. Range unbounded preceding to current row. And as each row streams through, it is the last row when you say up to current row. That's going to be a common mistake that I'm going to see in the wild. How do we fix it? One, we get rid of the range part, and we explicitly specify row, and we say unbounded preceding to unbounded following. 90. Much more efficient there, but actually still not efficient in this case as other solutions. They're not always going to be more efficient than other tools. Yes? Well, that's what the default is. And think about the way a stream of rows. Well, no, it's to current row. That's the one in the current stream. You can't go backwards and then say current row forward. Well, actually, you can specify that. But in this case, it doesn't help what I'm looking for, I don't believe. Okay. Yes? We have no tools. The question was, can you control this or configure it so that rows unbounded preceding to the current row is default? You cannot, there is no tweak that will allow you to change the default. Hopefully, Microsoft would work on making range more efficient or giving us a knob that we can say, I want this as my default or I want that one. Problem is that doing that, allowing you to change the default behavior, scary stuff, because now nuclear power plants melt down and patients die and airplanes crash because one system's configured one way and one's configured another way and you get different outcomes. That's not a pretty picture. Okay. Performance part, I really expect to see improvement in performance across the board in the windowing functions because they're just so fundamentally important. Yes? I actually suggest always doing range, whatever, rows, whatever your window is, whether it's unbounded to current, unbounded to following, minus 100 to plus 100, whatever. I would say for now, default to rows unless you see an observable effect that tells you need to switch to something else. Or, I mean, there's actually classes of problems where you have to use range, right? You don't want a particular number of rows. It's the value of them that becomes important in the query that you're actually writing. In that case, obviously, performance takes a backseat to getting the right answer.
I just meant to always specify.
Oh, always specify, yes. I did not understand the question. Always specify. Don't rely on the default. Okay. Even if you use the default, range unbounded preceding the current row, always specify it. Future people may not know what you know, and they may have to go in and modify or, take a look at your code or do something with it. Help them out by explicitly specifying, no matter what it is. Okay. Questions there? Any more? Flag and lead. Okay. More than first and last now, we have the ability to specify something other than the first or the last, like 4 rows ago, or 4 rows in the future. Or, future being in a stream, not necessarily a time series type of stuff. Okay. So select to compare values in the current row with values in a previous or following row. Okay? But it has to be in the same result set, and you can do a physical type of offset before or after the current row, but you can't do the frame for this one. but that still leaves a lot of things that you can do with this. Scalar expression, again, something that gives one value. That's a lot of flexibility. Offset, that's how many ago or in the future ahead. And then a default. And that's really important because if you specify like 4 rows ago, this is the first row, there ain't 4 rows ago. What's that? Null. And null may not be what you want to see on output. You may want something replacing that null that's meaningful, such as 0 or empty string. Okay. So you can actually specify if there's no value at that point that you say to go to, put this value in place of it. Over, partition by, and order by. Partition is optional, no framing. Okay. Default, if not specified for offset, is 1. Be explicit, right? That's kind of self-documenting your code, right? Relying on defaults in the language is really not a good thing as a developer or coder, in my opinion. Really is easier to understand and really flexible. Again, you can get really good performance because it's often a single pass through the table. And even if you have to do sorts, it can really be much more efficient, right? The previous subsequent row must be in the source result set, so you can't reference something from another, query. And you can't filter in the where clause based off of the window function itself, the lag and lead, right? However, with CTEs, there's a lot of things you can do, right? Or derived tables. I still use derived tables over CTEs in most cases. Lag and lead. AdventureWorks. Here we go. Correlated subquery. Select min where customer ID is less than customer ID. Well, there's that triangular join thing again, right? For every row, check all the rows before. We know the performance is probably not going to be good there. So there's a row, the next one. Okay. Looks like it's making sense from an answer perspective. Always be sure, though, as developers or coders or SQL people or database people, make sure you always test your boundary conditions, right? The first one and the last one, you got to look at those because that's where wonky things are going to happen, right? Also, if you allow nulls in your database schema or your values, make sure you test for null and not null stuff, right? And maybe you get the wrong answer if you don't do that. And not enough people do rigorous enough database testing as it is, so those are definitely some ones that you'll want to look at. So 2005, we can actually do this by row number over order by customer ID as row, and then join the CTE to itself on row -1. So sequence it, order it, put a 1 to n on it, and then join it to 1 to n -1 and get the same output. Okay? AdventureWorks is a really small database, and it took 46,000 IOs to do that triangular join, that less than for every row, and doing a row number over order by 250. Big deal. Big, big deal. So the query plan for that guy, just a merge join. 2 reads of the table. Right? If that's a 50 million row table, that might hurt. Lead, customer ID, 1, no default specified. Over, order by, as next customer ID. That's really straightforward. Answers look right. There's that long stream of processing. 1 hit on the table. Segment, sequence, segment, window spool. You'll see those over and over and over again. even more efficient than the row number. Basically half. Why? One hit on the table. Back in the 60s, some very smart people came up with these things called characteristic functions, precursor to what we now use as a case statement, that would allow you to do really, really cool things in a single pass-through data. Back when RAM was measured in K, not terabytes, right? And I/O was measured in kilobytes, or maybe perhaps you had a megabyte disk back then. So one pass through the table was extraordinarily important back then compared to what it is now with our massive compute power and RAM and SSDs for I/O bandwidth and things like that. So the ability to trade CPU ticks or anything for I/O is critically important in database processing, right? I'll jump through all kinds of hoops to do one pass through a table or to minimize the I/O on what I'm doing in a heavy query plan because I know that that's so much more efficient. Okay, and that's why we get a big benefit here, is because it allows us to do a single pass through the table. Okay. So if we do just one, we don't get the answer we want. But we can put it in a CTE and then do it, and we get the right answer. However, putting it in the CTE, in this case, if we wanted one subquery, is much faster because we've narrowed it down to one row. Okay? So use the right tool for the job. If you know you're going to look for one and it's next, don't use this, right? Provided to us now give us more capabilities to do pretty good statistical analysis effectively and efficiently within SQL Server itself. So we may see some pickup in the use of this within the engine itself. So cumulative distribution is a cumulative distribution of a value within a group of values. And if you don't have a degree in statistics, some of these may not make a lot of sense. Hopefully looking at the data, again, you'll have the sample code to take and play with at your leisure, and hopefully you can use that to understand what it does and then perhaps apply it to some of your query or reporting needs. On that one, percentage rank is the relative rank of a row within a group of rows. Okay, it is pretty similar to cumulative distribution. Then there's percentile discrete, okay, which is a percentage sorted out for values within a row set, possibly partitioned, but it is based on a specific value in the stream or the data set. Okay, the discrete must exist in the output itself, as opposed to the percentage must exist within one of those rows. Find the particular percentage that's in there. Now the next one is contiguous, which is actually a mathematical calculation that may or may not exist in the actual stream of data itself. And hopefully that will become obvious as we look at the examples here. So what time are we supposed to finish up? Is it 1-ish? Okay. So this is a self-contained demo here. We've got student grades. Okay, simple talk. simple-talk.com, I believe. 3-part blog post series there. You really, really need to go and review that. It will help you wrap your mind around what really can be some pretty complex functionality from a data processing perspective. Anybody? Questions? I thank you for allowing me to come up and speak again. And if you need any relational engine help, give me a buzz. Got some business cards up here, and I'll be standing around to answer some questions after if you need it. You want to take it back over, Kevin?